So we first need to understand some of the language that's going to be involved in this topic of parabolas. There are three keywords that I'm going to start off with to kick off this unit. And the first word is relation. The second word is parabola, which is what the topic is about. And the third word is quadratic. Now, a relation is best described with an example. So I'm going to type in here a linear graph. You can see the red line on the right and the equation up there on the left, y equals x plus 2. Now this is what we call a linear relation. Now the relation is, it comes from relationship. So there is a relationship between the x variable and the y variable that produces that graph. And the relationship for this particular graph is, if I pick a value for x, let's just say 1, it will tell me, this rule or this relation will tell me what the y value would be. And you can see on the graph there, if I chose x to be 1, then you would end up at here at 1, 3. So the y value would be 3. So the relation is the rule that connects the equation to the graph. And so you need to have an x and a y pair. So when you plug in an x value into whatever relation you have, you're going to get a y output. So that's what a relation is. So the next step is to understand what a parabola is. And for that, I'm going to change this equation just a little bit. I'm going to use the on-screen keyboard just so you can see what I'm typing. And I've typed here x squared. So now the relation is y equals x squared. So the relationship is whatever I choose for x, I have to square that number and that will give me the y value. And you can see the shape that it makes here. Now this shape is what's actually called a parabola. And a parabola can be two ways. It can be facing upwards like this. So it looks a little bit like a happy face. The technical term is convex. Or you can have it upside down, that blue one there, and that's called concave. The way that I remember this is a concave parabola. It makes the shape of a cave. You can see there the inside of the blue curve looks a little bit like the entrance to a cave. So we have a concave and a convex parabola. And a parabola, remember, is the shape that the graph makes. So the third word is a quadratic. Now, a quadratic is actually a particular kind of relationship. We had the original graph, it was y equals x plus 2. Now, that was a linear relationship. It made a linear graph. The y equals x squared, we call that a quadratic relationship. And it makes a parabola. The equation we call a quadratic. The shape that it makes when you graph it is called a parabola. So if I was going to change some of these rules up, so I currently have y equals x squared there. If I was going to add another one, say y equals, I'll start it off the same, x squared. But then what if I add that x plus 2 that was on the other equation? Oops, delete, plus 2. So now I've combined the y equals x squared with the very first line that we had, that linear relation. And you can see there, it's moved the graph. It's moved up quite a lot. It's moved to the left a little bit. But it's still the same shape. It still makes a parabola. So a quadratic makes a parabolic shape. So to understand if something is a quadratic or not, or whether or not it will make a parabola, let's try a little bit more. Now we know that this one here, y equals x plus 2, we now know that that definitely is not a quadratic. It doesn't make a parabola, it's a linear graph. So the purple line, that's linear. It's a linear relationship. There's the difference between the first two, the red one and the one I just got rid of, and this new one, this purple line. The difference is there's no x squared term, and that's going to be key. So in the first two, the red one and the green one, there is a squared term. There are other bits and pieces in the green one too. There is the x plus 2, but there is a squared term. And that makes a parabola. So then what if I go one higher in the powers? So what if I do x to the power of 3 instead? Well, you can see now it looks a little bit like a parabola, but then it flips halfway and it curves back the other way. this shape is not a parabola. It's not concave, it's not convex, it's kind of a little bit of both because it twists. So we know that an x squared term will make a parabola. We know that if it has an x squared and other bits and pieces, as long as it's got an x squared, that will make a parabola as well. But if there's an x cubed, it doesn't. So finally, what if we try something with an x cubed? I'll get rid of that one and I'll change the color so you can more clearly see the difference. So I've started off the equation the same, y equals x cubed. But we've been talking about how it has to have an x squared term if it is a parabola, if it's a quadratic equation that makes a parabola. Well, you can see now I've added an x squared term and it's changed the shape of the green graph just a little bit, but it's still not a parabola even though it's got an x squared term in it. So the conclusion that we can draw from this is that a parabola is formed when the relation is quadratic, and we know the relation is quadratic if it has an x squared term and no higher power. So what I mean by that is nothing higher than an x squared. It can have things lower like the x or the constant term like this one here, but it can't be higher. So if you have x to the power of 3, x to the power of 4, that relation is no longer a quadratic relation and it will not give you a parabola.